Morty, we've got to turn the project in early.
Hey, how's everyone doing? Good to see you here. Taylor Meredith Jackson. Chapter 15 quiz is making me so sad right now. No! Let's go do some Chapter 15 quiz. Let's go do some Chapter 15 quiz. Okay. Chapter 15 quiz, let's get it done. Which one are we going to do on the quiz? Which question are we going to do on the quiz? You name it, we do it. There's lots of new questions this semester. So which one should we do? I saw some people put some stuff in the chat about discrimination. No! Ma Pearson. Let's log in right here and do some Chapter 15 quiz. Chapter 15 quiz. It's a tough chapter, but when you get it down, it's an easy chapter. But we could say that about any chapter, about anything, about any course, about anywhere. It's like I could say to my nephew, I could be like, multiplication's easy. 5 times 5 is 25. 7 times 7 is 49. He'd say, how do you know that, Uncle Brian? I'd say, practice. It's only easy with practice. 8 times 7, 56. Let's see right here. We're pulling up the questions as we speak. Moving the notepad over here to the side. And which questions do people want to do? I dropped like 4 in the chat. Can you see them? Yeah, here, Meredith. Let's do the first one. Write the null alternative hypothesis you see to each test. Okay. So write the null and alternative hypothesis you see for each test. So at the very start of it, I saw one similar. Oh, I see it. Found it. There's a few of these write the null alternative hypothesis. So write the null alternative hypothesis. Okay. So here we go at 303, stat 201, chapter 15 quiz, write the null alternative hypothesis. Let's take a look at it. Here we go. Now, I kind of like the way this is worded, but there's an easy part to writing the null. The null always has the what sign. Whenever you're doing problems like this, the null always has the what sign. Like what you always want to know about writing statistical notation is the null always has the what sign. This is going to make solving any of these a lot easier. The null always has the equal sign. So when you're writing the null, you always want to make sure you do the equal sign. And then, which this problem really doesn't cover, I wish it did, we need to figure out what we are testing. All of these are testing the what. Like, is a four-sided spinner fair? Like the probability it comes out to one of the sides is 1/4. All of these are testing the what right here. Every one of these is a test on a what currently. Every single one of these is a test on a what. Every one of these tests is testing the what. The parameter of interest, which is the thing they're interested in testing, which is the first thing right there, the parameter of interest. All of those parameters are the what. Because it's not always this. But they're always using what? They're always testing the what? They are testing every time the true proportion. So they're testing P. So what do you think we're going to have to find for, well, they do it for us in this problem too. I wish they didn't. They give us the hypothesized value, and then it asks for the sign of the alternative. How do we figure out the sign of the alternative? How do we figure out the sign of the alternative? So this one right here only really wants you to figure out the sign. That's what they're testing your knowledge on. How do you figure out the sign of the alternative? How do we figure that out? From reading the question. So let's take a look at these. So the first one says, a prime minister is concerned about his negatives. That is the percent of the country's residents who express disapproval of the job performance. His political campaign pays for a series of TV ads, hoping they can keep it below 59%. So the null should have what sign right here? Don't even click the button. The null should have what sign? What sign should the null hypothesis have? The true proportion of negatives is what? Equal to 50%. And then they want to see that they can keep the negatives below 59%. So they're trying to show evidence that his true proportion of negatives when they do the campaign will be what to 59%. They're trying to show evidence that the true proportion of negatives will be what to 59%. They want to show evidence what here? They want to show evidence it is less than. Exactly. So that's the keeping it below. Is a four-sided spinner fair? So if it's fair, then the probability of one of the sides would be equal to what? Well, I just said it. It'd be equal to 1/4. The probability of that one side occurring, or the proportion of times it occurs. This was the one you're confused on right here. So if it's fair, you'll see it 1/4 of the time. But if it's not fair, you would what? So don't even look at the things right here. If it's not fair, then it would occur what? So if it's fair, it would occur 1/4 of the time. But if it's not fair, it would what 1/4 of the time? So like if you have a spinner, it's talking about a little spinner, and let's say you look at it and you think logically it's fair, it would not occur 1/4 of the time. You're right. So we're talking about a little spinner right here where it looks to be fair. And you're going to spin it to see which one it comes up on. And you spin it a whole bunch of times to see the percent of times it comes up on one side. And so how would we express it not occurring 1/4 of the time there? So it either occurs, the true proportion of times it occurs is 1/4, or what would we say to see if it's not fair? If it's not fair, then the proportion of times it occurs would be what? Not equal, exactly. Because there's no sidedness to this one. It's just saying, is it equal to 1/4 or is it not equal to 1/4? If it's fair, it should be 1/4 of the time. If it's not fair, it would be not 1/4 of the time. Great job. Only about 23% of people who stop abusing alcohol succeed. So we would expect that to stay the same. Sellers of a motivational tape claim that listening to the recorded messages will help people succeed. So they want to claim that the true proportion will be what? They want to help people succeed at stopping. So they would say that the true proportion of people who stop is greater than, and great job. That's just learning the one-sided, or knowing how to do one-sided versus two-sided. I like this one a lot more right here. This one's more complicated, but we can easily figure something out right here. The null always has the what sign. It's got a lot of options, but whenever you write a null hypothesis, the null hypothesis, wrong set of slides, the null hypothesis will always have the what sign, equals. So you can go right here to this question. If you know the null has the equals, you can just easily put in the equals for the null, and you've got that portion done. Now, the first thing right here will be the same for both of these. Notice how we've got options, and it's going to be the same for both of these. Whatever you select, and let's look at the notes again, whatever you select right here will be the same for the alternative. Now, we're not going to use all three alternatives. The alternative sign is going to be based on the question, but we are going to pick the parameter of interest, which will either be P, mu, or mu1 minus mu2. So what are the only options we can pick from on here? The only parameters of interest we can pick from are going to be what? The only parameters of interest we need to pick from are going to be what? Right now, we only have options between what or what. The only two we can really pick from on this list are going to be what or what. Well, mean is 1, which is mu. And then what's the other option we could pick for the parameter of interest? Mean is 1, or we could pick what? We could pick mean for mu, or we could pick what for proportion. So mean is 1 or proportion. And so proportion is for categorical data and mean is for quantitative. So what should you look at for this question? You should ask, is this a question that is asking a what or what question? So how will you know if this is P or mu? You have to look at this question and ask, is what they're testing here, and Jackson sees it, it's categorical. In 1950s, only about 40% of people graduated from high school. Did you graduate from high school? That's the question they're asking. Did you graduate from high school is categorical. I know that's a number, but it's proportions, like the proportion of people who graduate from high school. So did you graduate from high school is categorical. So that makes it P. The proportion of people who graduate high school is this. Has it changed? So what is that telling us there when we look at has it changed? That is telling us the what of the alternative. That is telling us the has it changed? Like, so it was 40%. So the proportion of people who graduate from high school is equal to 40% as the null. And then the has it changed is going to indicate the what of the alternative. So this is important to break down these parts. And not equal to Meredith. Is this making more sense, Meredith, as we go through this? That tells you the sign right there to be like, okay, so has it changed indicates the sign. So is the proportion not equal to that? 20% of cars need costly transmission work. So are we testing a categorical or quantitative thing to know the proportion of cars that need a costly transmission work? So are we testing categorical or quantitative right here? 20% of cars need costly transmission work. How does it change? Oh, because then it's like different. So has it changed? It could have gone up or down. So it would not be equal to. Good question, Jackson. So has it changed would be up or down, not equal to. And this is categorical. So has it changed means it could have gone up. It could have gone down.
It doesn't matter.
One of those ways. Has it increased? Like, are more people graduating from high school would be the greater than alternative. So right here, we want to see if the true proportion is equal to 20%. And then it says the manufacturer hopes that a redesign has solved this problem. So what if it hasn't changed, would it still be, then we would fail to reject the null, Jackson. Good question right there. Because if we fail to reject the null, then we would have evidence it hasn't changed. So the null would be that it hasn't changed, and the alternative is that it has changed. So if the manufacturer is trying to fix, and Jackson, great work. Got 3 some points there, Jackson. If the manufacturer is trying to fix this transmission issue, the manufacturer would be trying to show what? That the proportion of cars that have this costly problem has done what? The manufacturer would be trying to show if we might not want to say they've fixed it, but they've helped solve this problem, or if they've made improvements. Maybe that would be a better way of stating it. The manufacturer is looking for that the redesign has made improvements towards fixing the problem. So what would the manufacturer want to show? What would the manufacturer use as an alternative? The manufacturer is trying to show evidence what here? Because maybe they're being sued and they said we've taken steps to fix this. We want to show evidence that we've done this. So what way does the alternative go right here? So if they fixed it, what would happen to the proportion of cars that need the costly? Well, if it's greater than, this would say the proportion of cars that need costly transmission work is greater than 20%. So if it's increased, remember 20% is the proportion of cars that need costly transmission work. So 20% is the current state of where it's at. So if they haven't done anything, it would stay the same. And so the alternative that they're trying to show is that they're fixing the problem. And so the proportion of cars that need costly transmission work has decreased. Does that make sense? Yep. And so that's just what you want to see right here. You just want to try to read it. That says the alternative states that the proportion of cars that need costly transmission work, because 20% of cars need costly transmission work. So this is the proportion of cars that need costly transmission work has decreased from 20%. It's lower than 20%. So really good, tricky question. We field test a new flavor of soft drink planning to market if we're only sure that over 60% of people like it. So the null would be what? Is it P or mu here? And we give people a soft drink and we ask them if they like it. Is that P or mu? And so you might think, oh, they're going to throw the mu at the end. No, they don't for some reason. It's still P because it's whether or not you like it. It's categorical. Yes or no, do you like the soft drink? And so we will only market it if over 60% of people like it. I think this one's as straightforward as it comes. What's the sign of the alternative right here? This is a really good question. I love these. They're really great practice on writing it. Can you do that one that's probably hold on, example? Yeah, which one? Paste it again, Meredith, real quick. We'll do it next. Thank you, Meredith, so much. This is going to be the what alternative because we want to see for each of the given situations define the parameter. Oh yeah, we could do that. Yeah, I bet there's going to be some quant in that. Over 60%. So right there. These are really great questions. If you can write these out without using their examples, you're really good. We were doing that in class today. Check out in class today where we were writing out the nulls and alternatives. And so you want to be able to do this regarding customers have a default rate of 5.4. So that's going to be proportions right there. Let's go find that one. What's the very start of it? For each of these given situations. Okay, my gosh, so many questions. We'll find that one here real quick, Meredith. Thank you so much, Meredith. It's a sub question on the one I listed. Oh, is it? Can you put the very start? It's for each of the given questions, right? Let me find that. There's a lot of questions. All right. Thank you so much, Meredith. Some good short ones right there. Oh, you see, look, you can almost tell by looking at this. It's are higher. There's just some answers you can just tell by looking at them. All right, here for each of the given situations. Cool. So I like this right here. This is very similar to, here we'll take it because it has a different start. So if someone's looking for this, they might have it right here. Okay, so let's mark it. 15, 53, statue 1. Chapter 15 quails for each of the given situations. Okay. Here we go. Seatbelt companies in a certain state, seatbelt compliance in a certain state was 74% in 2008. The state wants to know if it has increased. Well, the sign of the alternative, let's do the easiest thing here to start, and we'll do all these good questions there, Meredith. What are you going to put for the sign of the null for all of these? So the sign of the null for all of these, just once you say it a billion times, you'll always remember. The sign of the null will always be the what when we write it out. What will the sign of the null be? That's the easiest thing to mark for all of these. It'll be equals. And not just because, oh, you're saying P already. Great job, Meredith. And that is correct, Meredith. Got to throw you some points for that. Meredith said already what it's going to be, P or mu, and it's P because it's categorical, and we'll see that here in a second. I'm just going to go through and mark all these signs because the null always has the equals, so that makes life a little bit easier. So we already know the null has the equals because we're going to state that this is the truth. We believe this currently. We're going to state a null hypothesis to test, which we might reject or fail to reject later. So now we have here the null, and we need to know the parameter being tested, and Meredith said P because it's categorical. You either wear your seatbelt or you don't wear your seatbelt. This is me wearing a seatbelt, like, you know, in like charades, and you're like, wear a seatbelt, put on a seatbelt. Guess you can't make sounds in charade. But that would be the proportion of people who wear a seatbelt, not the sample proportion, but the true proportion right there. Make sure to remember when you're doing this, there's only a few things we will put in there for the parameter of interest. I'm going to show it again here on the slides. The things we can put in for the parameter of interest are going to be P if it's proportions, mu if it's quantitative, or mu1 minus mu2 if it's the difference between two means. The hypothesized value will be known as P naught, mu naught, or usually test 0 for the difference between two means. And the hypothesized value can technically be anything. This is sometimes called a lambda, like a change in, or is it a theta? I forget the notation we use for that because I don't write the notation for that one very much. But we usually test that there is no difference. More on that in chapter 17. So once again, we need to know what we are testing right here, which is the first thing, and it's the proportion of people who comply. So over here, you'll put the same value you put. Don't change it up. If it's P, it'll be P right here. If it's mu, it'll be mu right there also. And then we want to know if it has increased. So that indicates the sign of the alternative, which is the greater than sign. Last year, a survey found that 43% of employees were willing to pay for on-daycare. So on-site daycare, is that quantitative or categorical? Like if you're willing to pay for on-site daycare, is that quantitative or categorical? If you're willing to pay for on-site daycare, is that quantitative or categorical? It's categorical. So since it's categorical, that means we're dealing with P here again. And they want to know if it's decreased. So what's the sign, Meredith? So the company wants to know if it has decreased. So what's the sign? I would try writing these out without their prompts, and you really get it down. You get down choosing what the parameter is, knowing the null has the equals, and then the hypothesized value, which is what they are assuming is true. Regular card customers have a default rate of this, so you either default or you do not default. So what would defaulting be? Categorical or quantitative? A credit card bank wants to know if the rate is higher for their gold cards. So it's categorical again. Cat command all in the chat right there. Sarah, so good to see you. We got buns in the chat. We got cats in the chat. Bun and bunnies and all those. So that is going to be categorical again, and they want to know if it's higher. So we got that. Regular card customers have been with the company for an average of 17.2 months. The credit card bank wants to know if their gold card customers have been with the company on average the same amount. Okay, so now we're saying how long have you been with the company? So how long you've been with the company should be what? How long you've been with the company, is that cat or quant? How long? And there's also a clue because this is not between 0 and 1. And do you notice how every other number, now this doesn't mean it's proportions, but proportions have to be between 0 and 1. So because this is not between 0 and 1, either they're expressing it as a percent, which they're not, but because it's not a percent and it's not between 0 and 1, that almost instantaneously means it's quantitative, which is a quantity of months you've been with. Yeah, there's a lot of little tricks to figuring out, like, okay, wait, proportions are between 0 and 1, but watch out. Like if we ask people like, like how much of a pizza do you eat? Well, because that's not because then we could ask someone like, here's a pizza, how much do you eat? And one would be the whole pizza. And then we could say, what is the average proportion people eat of a pizza? That's really confusing because it's saying proportions, but that's actually the mean proportion of people eating of a pizza. I would never throw that example out, but that's where we could throw really tricky problems because you have to look at the question. It's how much of the pizza did you eat, which is a quantity of pizza. Now you could record it as like, how many slices did you eat? And that'd be easier to represent. Or we could like look at the weight of pizza you ate. Like we could take the starting weight of the pizza and subtract. There's so many ways to do statistics, but you always want to look to the question asked, which is how many months have you been with the company, which is quantitative. But then there's a lot of ways to look and be like, well, proportions are between 0 and 1. So this is not proportions. Then we want to know, it says at the end right here, the credit card bank wants to know if their gold customers have been with the company on average the same amount. So what should the alternative be? So they want to know if they've been with them the same amount. So we know that the one customers have been with it 17.2 months, and we want to know if the other customers have been with them the same amount. So what would we do right here? What would we do right here? What would the alternative be? The alternative would be what? Well, the null has the equals. So the null has the equals, and the only 3 signs for the alternatives are the following. So which of these looks more like the not equals, right? So the alternative is going to be the not equals right here. There we go. That should do it. Woohoo! Because you're either with the same or you're not with. Exactly. Either they're the same as, which would be the null. So we're assuming without evidence, we're going to say, well, they're probably just about the same as our other customers. Like, think of your best like assumption. It's like, well, this customer's like this. These other customers are probably like this. So then we're looking for evidence right now that they're different. So the evidence would be that they are somehow different than our regular customers. Good questions right there, Meredith. Really good practice on writing the nulls and alternatives, which we do some during class. Then we go right there. Company is criticized. Is that this chapter? The company criticized? That sounds like, yeah, because it gives the numbers. The other one does it, but does it with a hypothetical. Okay, let's see here. A company is criticized. There we go. A company is criticized. A company is criticized. Oh, there it is. Okay. Company is criticized. A company is criticized. Here we are. A company is criticized because only 14 of its 43 executives at a local branch are women. The company explains that although the proportion is low than it might wish, it is not surprising value given that only 40% of all of its employees are women. The company has more than 500 executives worldwide. To test an appropriate hypothesis, state the conclusions, or state your conclusion. Okay. So with this problem right here, what are we testing? We are testing the proportion of executives who are what? We are testing the proportion of executives who are what? We are testing the proportion of executives who are what? So what are we testing? Proportion of executives who are women. So when you look at this, if we have 40% of women at our company, what proportion of your executives would you expect to be women? If you have 40% of your executives are 40% of your company is women, what proportion of your company would you expect to be women for the executives? If 40% of your company is women, what proportion of your executives would you expect to be women? So 40% of your company is women. Exactly, Meredith. Great job right there. And then if they're discriminating, then you would expect the proportion to be what? So proportion of executives who are women is equal to 40%. But if they're discriminating, then you would expect what? Less than. Does that make sense? Less than right there. Say, well, like maybe, like let's see if it's lower than we expected. Write out the alternative. Yeah, awesome, Taylor. We can do that one here soon. I think, did we do those? We did some write the null and alternative. We might have done those, Taylor. Check out the start of the video here at 3 minutes in. We might have done those. So good question right there. Hey, Victoria, good to see you here. And so now they jump into it. Now they want you to find the Z. So Meredith, what is this going to boil down to? What is this question really going to boil down to right here, which we talk about all the time for knowing this? And this is a really great question. What is this going to boil down to? Knowing that notation.
Notation, brother.
So now we need to mark this. Tell me the colors of what these things are. Okay, tell me any of these colors right here. Oh, we're tailoring down here soon. You got it. Tell me the colors of any of those. What are the colors of any of those? Close. That's a tricky one. So this one right here, capital N, which we won't use. That's population size. So they're being tricky on that. That's to check the 10% condition if you want. So that's population size. Yes, great job. And there's only 2 more things to identify. It looks like we have a lot more, right? There's only 2 more things to identify. Great job, Meredith, right there. So this is X, right? There we go. And yep. And then what else? And then you've basically got it. What else are you missing now? You're only missing one more component. What is the last thing to identify? What is the last thing right there? So now we have P naught. What else can you find? You know, P naught is equal to 0.40. Then Q naught is equal to 0.60. So does that make sense? P naught and Q naught are complements. So once we find that, we can find P naught and Q naught. And then we plug in. What do you immediately notice about the sample proportion? Ooh, good question, Sarah. What do you immediately notice about the sample proportion? Look at the sample versus the hypothesize right there and be like, huh, that's going to be interesting. We'll see which way this goes. But the sample proportion is what to the hypothesized value, which is what we would assume is true if they really don't have any discrimination going on. So, yes, it's a little bit lower, right? Oh, wow. That's interesting. So the z-score is basically what? The z-score is basically what? The z-score is basically what? You might even round to that. The z-score is basically what? And be careful, not 1. You're basically right there, Meredith. Great work. Not 1, but -1. Basically. It says round to 2 decimals, so -1. And so, great job, Meredith. It's basically -1, and this is going to be very interesting now for the problem. Because with a z-score of basically -1, then the p-value to 3 decimals, I think, is 0.158. And let's check our work right here. Let's go over to the David M. Lane So here's the David M. Lane right here. And which way am I going to shade on the curve? Why am I shading this way right here, Meredith? There it is right there. It's 0.159. So why am I shading to the left? Why would I shade to the left of the curve? Why would I shade to the left? Why would I shade to the left? Because the less than alternative, exactly. So the sign of the alternative indicates which way you shade on the curve. So we're shading below because the less than alternative. So make sure to look at your sign of your alternative. Go to -1 on your Z for your Z-score. So when we put in the Z-score right here, and you don't need these other values, they might just confuse you. And then we have -1 and less than, and there you go. State your conclusion. Oof. Well, using an alpha of 0.05, because the p-value is what? Is the p-value here high or low? What is the p-value? Is the p-value here high or low? The p-value is high. Because the p-value is high, we fail to reject the null. So since the p-value is high, we fail to reject the null. These data do not show that the proportion of women executives at companies is less than 40%. And yeah, it's a little bit lower, but not lower than we would have expected due to random chance. So exactly, really good work right there. Pretty tough question. So yeah, good stuff. You're welcome, Meredith. Great job. There's a lot of questions on this one, so a lot of good stuff. I think Taylor has the next one, a consumer group tested 11 brands of vanilla yogurt. Okay, let's mark that right here. That was a really good question. Stat 201, chapter 15 quiz, a consumer brand tested. Here it is. Okay. So wait, did we do this one earlier? Did we do a consumer brand tested? Why don't we do it again? No, this one's got the data. We didn't do one with data. Okay, so for this one, you're going to need to use jump. Jump's going to make this way easier. You could do it by hand, but I highly suggest using jump for this question. So let's take a look. What is condition 1? What is always condition 1 every single time? What is condition 1 every single time? Who knows condition 1 for 1,000 points in the chat right now? What is condition 1 every single time on document number 76 right here? Condition 1 is what? Condition 1 is randomness. Sometimes Mike Pearson checks this with the independence condition right there, or the independence assumption. It's more of an assumption, like if things are independent, then we should have collected them randomly. We want to collect less than 10% of the population. And then you need to pause and ask, is it quantitative or categorical? Quantitative is going to be Mr. T with the T distribution with means. And so we're going to use the nearly normal. Success failure is going to be categorical with at least 10 successes, at least 10 failures checked by NP0 and Q0 when doing tests, because we don't know P, and our best guess of P right now is P0 because P equals P0 according to the null. So with this right here, these are the conditions, and they're going over them here to start the question. The independence assumption, I would say, has not been violated. That would mean we have a problem. So they collected 11 brands of yogurt and found the numbers below for calories per serving. Okay, so I don't see a reason it's been violated. The nearly normal condition right here is plausible, and let's take a look. You want to take your data, copy to clipboard, and hit Control-C. So once you've got your data copied to the clipboard, go here to jump and go to File, New, Data Table. File, New, Data Table. Under File, New Data Table, you want to go to Edit and then Paste. Don't paste with column names, and don't click inside of here. Here is your data. There's an extreme value there, little low values. It's kind of normal-ish. We'll see how it looks. So now you want to go to the very top and go to Analyze Distribution. Analyze Distribution. Double-click the column right there and click OK. Analyze Distribution and double-click the column and click OK. The data, we're going to click Stack. I don't know. It's a little weird. It's a little weird. How are they going to say this looks? It's a little weird. It's got a little bimodality to it. Yeah, it's normal enough. That's fine. It better say it's fine. This is a normal probability plot, which is the plot that shows us the probability it's normal. If it follows the red line, it's normal. The more it deviates from the red line down the center, the less it's normal. Bins on histograms can look a little bit weird. Little centrality right there, little centrality right there. So like little bimodal, but normal enough. It is plausible. I would say, as they say in this problem, it is plausible, and we should use. Mine looks way more weird. Did you do the normal quantile plot? So go right here and go to the red arrow and go to the normal quantile plot. If it mostly follows the red line, you're good. So don't worry too much about how the histogram looks, because bin widths on histograms can be deceptive. It could look something weird with the bin widths, which are deceptive. But go by the normal quantile plot, which is a lot better way of looking at it. Yeah, the normal quantile plot is going to look the same because there's not bins for the histogram. It's just going to show you if it follows the red line or if it doesn't follow the red line. Last but not least, we could do a goodness of fit test. Is just one more way to check it. And you'd want to go over here and see that it actually passes the goodness of fit test, both of them. Shapiro-Wilkes actually very high, way higher than 0.05. And because it has a high p-value on the goodness of fit test, we would assume that the normal model here is a good fit, even though it looks a little bit weird. So all of that just to say that we probably passed the nearly normal condition. And that's when we use the T. So they want to test if 120 calories is the true mean. So remember, this is quantitative. So what would be the null hypothesis? What would be the null? So try writing the null without clicking one of these buttons. What would be the null hypothesis for testing? It'd be equals, right? But what else? What would we write right here? Diet claims that you get on average 120 calories from a thing of yogurt. So what would be the null? You are right. It is 120 equals 120. What equals 120 though? Really good practice right here, Meredith. And great job. We got 3 more points. Meredith, we're throwing you another 10,000 points. Mu equals 120. Meredith, you're getting it down because it's quantitative that we're testing. So it'd be mu equals 120 is the null. And then they don't give a sidedness to this. They don't mention if it's greater than, less than. We're just basically seeing if you get that 120 calories. So mu equals 120. We are saying the true mean calories you get is equal to 120, or the alternative that you're not getting 120. Now, this seems really complicated. If you're doing it by hand, it's more work. But the good news is we're doing this in jump. By doing it in jump right here, we can actually just go up to here and go to test and go to test mean. So this is under the red arrow and jump, and go to test and then test mean. Once you go to test mean, you can enter in the hypothesized value of 120. And with the hypothesized value of 120, click OK. And take a look at what you have. These are the results we're looking for right here. And now we need to know how to read this output. Let's go ahead right here and review what this output means and how it relates to everything we've been learning. The first thing you get right here is the mu naught value. So mu naught was our hypothesized value. The actual estimate, it's weird that it says actual, is y bar. The degrees of freedom are n minus 1, and the standard deviation is s. There's the t statistic that it wants. That's the t. And then we are looking for the does not equals alternative p-value, which is the first one. So we are looking for this p-value right here, which is the amount of shaded on both sides of the curve, and that t statistic of 1.54. So that's got it. That's what that output means right there. 1.54. And the p-value, which it finds for us, which is so nice. P-value of 1.54, 0.1. That's weird. It's a very weird problem. Never seen that. State your conclusion. So, Ali, this is, or Meredith right here, this is the part we need to get down. What are we going to do right here? Our p-value is what to alpha? So don't even look at their answers. Have it down to be like, oh, my p-value is this to alpha. Then I what? We do not reject, right? It's high. So since our p-value is above alpha, we do not reject the null hypothesis that 120 is the average amount of calories you'll get. There is not evidence to the alternative that you do not get 120. So we do not reject the null, which is fail to reject, same sort of wording. There is not sufficient evidence for the alternative because we did not reject the null that it is different from 120. There is not evidence for the alternative. Conclude that the mean number of calories is different from 120. Check answers 100. That's what we like to do right there. So practicing these, getting them down, understanding the notation is key, but also make sure to know how to read jump output like this to know that this is the hypothesized mean, which is mu naught. This is the estimate, which came from the sample. It was higher, as in the t statistic is above the null value. The null goes at the center. And this is where the y bar was at right there. And then this is the greater than alternative. And then below it, which they didn't shade, is the less than. So it's just that p-value is really big, and we would not have evidence that's lower than 120 if we landed above in our sample results. So yeah, really good question right there. And I think Taylor had another one. What's Taylor's other question? Wait. Drop more questions. The National Center for Education Statistics. $41. Okay. We're at the National Center. That's a good one. The airline one's pretty tricky. Okay. Here we are. The National Center for Education Statistics monitors many aspects of elementary and secondary education nationwide. Their 1996 numbers are often used as a baseline to assess changes. In 1996, 31% of students reported that their mothers had graduated from college, and 2,000 responses from 3,891 students found that this figure had grown to 32%. Is this evidence of a change in education level among mothers? This question has changed from last semester. Lindsay, good to see you here. So let's identify the notation of this problem before doing it. What is the notation right here? I'm going to highlight things that you should know notation-wise. Can anyone tell me any of the notation? Hey, Corbin, good to see you. What is Bracy? Good to see you too. What is any of this notation? Any of this notation? P is point. Well, we don't know what P is. So very close, Meredith. Very close. So it's not quite P because we don't know what the truth is right now. So we don't know what the truth is. P naught. Great job, Lindsay, right there. We got some big points for Lindsay right there. That is correct, Lindsay. P naught is the hypothesized value. So P naught is what we're going to hypothesize is true. So this is P naught, which we can use down here to say the null hypothesis is that P equals P naught, and that's going to be very important in a moment. Keep going. We only have a few more things to note for the notation for this. I'm being tricky by highlighting every single number. There's only two more to care about. So what else do we have right here? What else do we have? There's only really two more things. What two other things are there? And sample size. And what else? So from a sample of 3,891 students, we found that 32% of their mothers had graduated from college. From a sample. So what's the 32%? So from the recent sample, 32% graduated. From the sample, 32% graduated. So what would 32% be? Not X. So X will be a quantity. Good answer there, Lindsay. X will so what is P hat in words? What is P hat in words? P hat stands for the what? So X is the amount of successes. And then P hat is the what? So, well, we're wondering what is this thing right here? X is amount of successes. Well, no, that's P hat, Lindsay, right there. So, Lindsay, that'll be P hat. So, X is the number of successes, and N is the sample size. So, what is 32% right there? Well, so remember, P hat is a proportion, so P hat must be between what and what? P hat must be between what and what? I think you're on the right track, Meredith. I think you found something, but it's something else. You're on the right track. This is why we practice the notation every time. So what is that 32% thing right there? It's not Q naught. So wait, let's read it again. You ready? Good answers, everybody. Good practice. I'm throwing another 10,000 points just for the practice. I don't know if Mubot saw that. We'll see if he sees that, and then I'll type it again. In 2000, responses from this many people, which was a sample of this many students, found that in the sample, 32% of them had mothers who had graduated from college. So in the sample, 32% had mothers who had graduated from college. So what is 32% as a notation? In the sample of 3,891 students, 32% of them had mothers who had graduated from college. So what is 32% in notation? Because it's 32% of the sample. So what is 32% in notation? So remember, it came from a sample, and it's a percent, which sounds a lot like a what? Don't worry about being wrong. Just give it a shot. So it came from a sample, and it's a percent. Here, I'll start writing some more notation down here. Not Y bar, because Y bar is quantitative. Good answer, Jackson, right there. Y bar is for quantitative, which is the sample mean, but you're really close. It's an analogous thing for this problem like Y bar, which is the observed result from a sample for quantitative data. Well, it's not the truth because it came from a sample. It's p hat. So it's not the truth because it came from a sample. So it's a sample proportion. So you'd say in this sample, the proportion was this. Does that make sense? Really good practice. That's a p hat right there. And so Meredith, what did you find right here by taking, I think Meredith went 32% of 3891, which is weird that it comes out as a decimal. I guess they rounded 32%. But Meredith backworked to find what? Meredith actually found, because Meredith did n times p hat. So n times p hat would be equal to what? So you need to type one letter. Meredith actually found what right there? So that value you found, Meredith, was actually what? Which we don't need for this problem, because you could take that value right there and divide it by 3891 and get that right there. So if you times this by the sample size, Meredith found the number of successes exactly. So you found X. So by doing that right there, you actually, does that make sense, Meredith? You're like, oh, okay, wait. P hat times N is X. We don't really need that for this problem because it already gives us P hat. It didn't give us the number of successes, but the number of successes must be like this right here, which when you divide it by 3891, it's basically 32%. They just rounded it. So that is the number of successes, which we don't really need for this problem. Yeah. So good job on the notation. A lot of this problem is solving the notation, because from here, we're just literally going to plug in the numbers. So once again, write down your notation, know how to solve it, and then you go here, and you do 0.32 minus 0.31 over square root 0.31. P naught equals this. And we'll go there, and sample size 3891. Find the z-score. Oh, gotta do the bottom first. 31 times there we go. And there's the z-score. 1.35. Okay. So now with a z-score of 1.35, we're looking for evidence that this has changed. So evidence that it is changed is the what alternative? Evidence that it has changed is the what alternative? Evidence of a change is the what alternative? Evidence of a change is the what alternative? So what would be the evidence is change? We're looking for the what alternative, the greater than, less than, or not equal to alternative. Evidence of a change would be looking at the greater than, less than, or does not equals alternative. The not equal to. Exactly. And so that's the not equal to alternative. And so that means when we go down here to our curve, we'd go right here to the curve and we'd graph 1, 2, 3, 1, 2, 3. We put where our results landed. Here's our results. It landed right here at 1.35. Then we graph down here at negative 1.35. We shade above the curve and we shade below the curve because it's the two-sided does not equals alternative. This is going to be a p-value. I'm going to estimate here for a moment. P-value about equal to p equal value. So it's going to be a p-value about equal to 0.087. Let's find this out. Where are we going to go? Does anyone know where we're going to go to find this answer? Where are we going to go to find this answer? Who can help me out right here to find that answer? Where are we going to go? Where are we going to go? David M. Lane in the chat. We're going to do that right there, and it gives the z 1.35, p-value to 3 decimals, 0.087. State your conclusion. I fail to reject. There is not evidence that it has changed. Check answer. Wait, what? Oh, the difference. Wait, we didn't reject. It's going to be weird here. Let's find out. Let's go to David M. Lane and see if I got it right. Okay, so David M. Lane. And we want to go to the outside for the does not equals. Negative 1.35, 1.35. Oh my gosh, I'm wrong on my numbers today. I was thinking of 1.645. Yep. Good thing I'm checking it right here. I guess maybe I should have doubled it too. 0.177. Oof, Brian, you'd have been way off on your guesstimates today. 0.177. Good thing we went to the applet and put in our answer right there for it. Good stuff. Do you think the difference is meaningful? The difference is probably not meaningful. So they've changed this one up this semester. So the difference is not meaningful because it is not statistically significant. They've changed up the way this question goes because it used to be statistically significant. So this is a conversation right here on the difference between practical significance and statistical significance. Statistical significance just means p-value less than what? Statistical significance just means p-value less than what? Statistical significance. This means p-value less than alpha. Alpha is assumed to be 0.05 unless otherwise stated. So does that make sense? Great answer, Meredith, right there. P-value less than 0.05, which means your p-value is less than alpha, and alpha is 0.05 unless otherwise stated. Practical significance. So practical significance, 1 must be statistically significant. Because anything, you see they're playing games with you then. Yours might be. So this is where your answer will be different from mine, Meredith, right here. So could yours be practically significant? So with practical significance, could it be practically significant? So could yours be practically significant because your p-value is less than alpha? Could yours be? So that doesn't mean it is. And I think what you said is correct. Yours could be practically significant. And then the next thing is, do I care about this difference? This is the hard part. So yours could be practically significant because it is statistically significant. Things that are not statistically significant are differences that are likely due to what? Things that are not statistically significant, like my version of the problem, is the differences I saw are likely due to what? Like the differences, they're likely due to random chance. Like it's just random chance differences. So that can't be practically significant. So mine should be, this is for my version, the difference is not meaningful because it is not statistically significant. That should be right. Ooh, no. It's not statistically significant. There's not has changed. We failed to reject the null hypothesis. You better not done it. Where's the alpha level? Did I use the wrong score of 1.53? Ooh, my Pearson made a mistake on their problems. So they've changed this problem this semester. and they've created an error in their problem. This problem is different this semester. It used to be perfect attendance. This used to be like, I'll literally pull it up, and I want to actually see it. So we're going to go look at this. This used to be called the perfect attendance problem. And I want to see what they did to this. Attendance. It's called the perfect attendance problem. It'll be towards, here it is right here. We're going to see long hair Brian solve it. Long hair Brian, show us the old version of this problem. You think I'm joking about long hair? You think I'm joking? You think I'm making jokes right here? Where are you at, long hair Brian?
17.
Long hair Brian right
Which
there.
ones am I missing?
Who knows? Give it a few more months and I'll get there again.
I don't know.
I don't know.
Big Bang.
You don't know, Brian? Wait or waitress problem. Okay. Is the attendance on here? Chapter 15. School attendance. My gosh. School attendance. Change this problem on me.
So here we go. Let's go ahead and take.
It's gonna be. Okay. Let's see the very end of it. So I want to know how they changed the wording.
Threshold right here. Using that.
So there we go. Using an alpha of that. Oh, this looks just like yours right here.
The HGT, isn't this?
We'll see this right here because there we go. There's that. And where's the last portion? Here it is. Well, no, they still got this. Let me look over our version of the problem. Long hair Brian, you doing all right, man? Okay, let's see. The difference, they're saying this is the answer. The difference is probably not meaningful. The observed change in the sample size is quite small. So even though it is statistically, but it's not. Maybe I got a weird version. So be very careful. I don't know if I got a weird version or what, but my p-value is correct. And so I'm very unhappy with this problem, which I've known for a long time. Maybe they made a problem with it when they updated it to the new mothers version, where it's like people's mothers graduated. But this is a slightly different version where maybe they broke something because this answer should be contingent on the previous one. Please tell me yours is statistically significant. So the first thing to check when it comes to practical significance is it must be statistically significant for it to be practically significant. And then you ask, do I care about the difference? Let me ask, just to review, are my results statistically significant here, yes or no? If you got this one wrong because of this, let me know. But are my results statistically significant, yes or no? Look at the p-value. Are my results statistically significant, yes or no? No, they are not. So it does not make sense to say, so even though it is statistically significant, no, it is not statistically significant, which means p-value less than alpha. So the p-value is not less than alpha, unless otherwise stated 0.05. So this is an issue. I'm not joking. I was like, that's weird that I got it wrong. And we're not going to ban this question. I'd like it otherwise. Really, I don't know what they did to it. And when it's not statistically significant, what do you do to the null? Which even confirms right here, if your results are not statistically significant, what do you do to the null? If your results are not statistically significant, what would you do to the null? You fail to reject. So that is even confirmed right there in that we failed to reject the null because we don't have statistically significant results. So there is a problem with this, and the answer should be for this last one. The difference is not meaningful because it's not statistically significant. So it should be this right here. But unfortunately, it looks like it's going to be this one no matter what, which is kind of a bummer because then they could test your knowledge that something must be statistically significant to be practically significant. Because if it's not statistically significant, it could be just due to random chance. So I really wish they would have tested that knowledge right there. Good question. Did that answer everyone's? So my p-value is with an alpha. So Lindsay, you would reject. My p-value is 0.05. Is it exactly? Your p-value is exactly 0.05, Jackson? Like exactly? Let me know, Jackson, if your p-value is exactly that. And what other ones should we do right here? Exactly? Well, it looks like no matter what was your alpha level? Here, Jackson, really quick, tell me your numbers from the problem. Tell me your sample size in the problem. The airplane one? Yeah, put the airplane one in the chat. We'll do that. Thank you so much, Meredith. Tell me your sample size in the problem right here, Jackson. And is it 31 and 32% in your sample size? Airline. I'll grab that right here. So drop your numbers, Jackson. I'll double check your work. We'll see. Let me get airline one pulled up. An airline's poll question. Everything was the exact same as yours, except the sample size was that. Okay, cool. Okay, let me look. Okay. So your sample size was that, you're saying. Okay. So everything was the exact same except 8213. So wow, I see what you're getting right there. Wow. So yeah, that's 1.96, the classic 1.95, 1.95996. Your p-value is going to be slightly greater than. I'm going to do this in R to get the exact p-value right here for you, Jackson. I think it's slightly greater. My gosh. So if it's at or above alpha, you fail to reject. So I think it's like yours is going to be super close. Just tell me if you get it wrong, Jackson, because this one is so close. No, p-norm. 1 minus. There it is right there. Yeah, it's slightly. There it is. So it's just barely above it, Jackson, which I see what you're saying with the decimal rounding. So here's your extra decimals on it, Jackson. It's just barely above. So you should fail to reject. And if you get it exactly 0.05, you fail to reject too. So you only reject when your p-value is below alpha. So be careful. What is your alpha though, Jackson? And then we'll do the airline one next. What alpha did it say to use? It said use an alpha of what for that problem for you? Like what alpha level, which is going to be very important. Well, but what alpha level though? Is it 0.05 or 0.10 alpha? Because they'll use different alphas. What alpha level does this here right there? Because that'll greatly determine the result of statistical significance. Is it a 0.10? Ah, so that makes it easy. So yeah, that's going to be, what do you do, Jackson, right there, reject or fail to reject? With your p-value of 0.05, so it is still, exactly. So there you go right there. That just makes it nice and easy because your alpha level is 0.10, p-value below alpha, done. So exactly, you reject, and there is evidence that it has changed. Good work, Jackson. And then the last one will be the same. It's probably not significant. Like, we probably don't care about it. Good work, Jackson. Good stuff. Yeah, so the alpha level just made it a nice and easy problem at the end that we didn't really have to worry about it being so close and do those exact calculations. Maybe they do that for that version. Maybe because it looks like they purposely figured out like the sample size needed to get exactly a 0.05, or maybe just got kind of lucky on that. What do you think we're going to do here at the start of this problem? What do you think this problem boils down to right here? What do you think this problem boils down to? This problem is going to boil down to what? No, Jackson, great work. Just the fact that you saw it and then you're like, oh. What do you think this problem boils down to right here? This problem is going to boil down to what? Your what? Knowing your what? We all know it. We all love it. It's going to boil down to knowing your what. For the project, is each component supposed to lead to one final explanation? Yeah, the intro, the executive summary, and the future research. Yep, those will be the summary of the project and the where we're going to go from here. Good question, Kyle, right there. Notation, brother.
Notation, brother.
So what is any of this notation in this problem? So an airline company claims 89% of luggage that is lost is recovered and delivered to its owner within 24 hours. So what is any of this notation? It is a tricky one. What do you think? This one might get me because I know how this problem goes and I know what I want to write. P0. And then make sure to do that as a decimal or as a percent. P0 is the hypothesis. Do I need to pick the data with the goal of proving something in order to... Well, you don't have to prove anything. You just examine, and whatever you find, you find. Good question, Kyle, right there. If you find some stuff interesting, you do. If you don't, you can say that you didn't. Then you can say what you investigated. So the goal is to do some investigations, and if you find some stuff, you find some interesting stuff. If you don't, that's right, you talk about it. Good questions, Kyle. And then what are the other ones? Bet. We don't have the betting turned on. What are the other notation things right here? There's really only 2 more to go. So they found that 115 of the 180 passengers. Great job, Meredith. Excellent work on this. Thank you so much, Meredith, for being here. Sample size, right? You're welcome, Meredith. N is 180, and then what else do we have? We used, well, I used to do betting on questions. I used to. You watch any other streamers who do that, Kyle? I figured you might have known of the Streamlabs thing that you can bet things. All those internet streamers. So there we go. We got the problem ready to go. So the first step, like Swifter on Twitch. Oh, cool. Yeah. Awesome. Yeah. No, if they're using Streamlabs, they've got the same options on like betting points and stuff like that. Or you can like do duels and crazy things. I was like, the commands. I'm running Streamlabs chatbot, my chatbot in the background over here, doing all the good stuff for me, tracking the chat, a lot of fun stuff. Thank you for, I've thought about using Twitch, but you can't do unlisted streams. So like, if I'm teaching class, we don't want just random people showing up and being like, hey, what's this? And we're like, I'm teaching college students. So it wouldn't be productive for class. We've had random people jump in before, but let us coin flip. Yeah, they can. There's a lot of things that you can do with Streamlabs chatbot. I'm always trying to look at new things. They really haven't updated it much in the last 2-3 years, but thank you to Streamlabs for doing that. So pretty good. I used to use Streamlabs OBS. You can see down here I'm running OBS, and I guess I took Streamlabs OBS off my chat bar. $300,000 point coin flip. Oh no, you never know, right? Hey, Ivana, have a great thanks, or I hope you have a hope you had a great Thanksgiving too. That's awesome. Thank you for that. P hat minus P naught over P naught Q naught over n square root z equals 2, and P hat is 0.63880. There we go. Oh my gosh. There's the bottom part of the equation. Now the z-score is going to be ridiculous. -10.77, negative 10.77. So when you look at this right here, what do you think we're going to do if we land 10.77 standard deviations below the null hypothesis? The null hypothesis of P naught was right here, and we landed 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We landed all the way down there. So did we land anywhere near the null? Did we land anywhere near the null at negative 10.77? Did we land anywhere near the null? Are the conditions met? Yes. The null is that we would believe the airline, and the alternative is less than. I'm a little bit scared on that one because I don't know if they're doing the greater that does not equals 2 test. So the z statistic we just found was negative 10.77, and the p-value is going to be 0. I'll show you how we know that right here, because if you go over to the David M. Lane and you go to below, negative 10.77, it's 0. It's so far off the curve that you can't even see it. The area below this, which is what we're graphing, is going to be nothing, nothing, nothing. There is no area. Well, there is technically area. We could use something like R here to tell us the area below the curve at negative. Well, let's do it over here. This is, if you really want to know how much area is below the curve down there, you have to use something like R to get the value. And it's that, which is a ridiculous number. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. I think I did about right. It's about this, or maybe one more zero I might have miscounted. But that is the percent of area, which is the p-value. And yes, I did it correctly. Hey! So there's the p-value right there. It's ridiculous and ridiculously small because there's basically no area, which means we are going to reject the null hypothesis. I'm a little bit afraid on this question, so be careful before turning it in. Check your answer with mine right here. We are going to reject the null. Does this result for the one-sided? I use the gender and number of piercings in the box for the male side. Sounds about right. And didn't get a box plot for the male side. But is gender a 2-level or 3-level variable? How many levels are gender? Like, do you see 2 box plots or 3? What do you see when you do it? Do the results of the survey cast doubt on the airline's claims? I just got points. It's just males and females. Okay, good deal. So here, I'll take a look in 2 seconds. Kyle, you got it? The results of the survey cast doubts on the airline's claim. Yes, since the null is rejected. I always love this question right here. And I'm a little worried if we got something wrong, it's because of the alternative and they want to use the 2-sided. But I'd want to show evidence that less than. Oh, we did. Woo! Because that's what I'd want to show evidence of. They really don't make it clear. That's going to be wrong right there. Wow, you get 20 points off for that. Either way, the p-value would be the same. So if you did select this, just let me know and say, hey, Brian, it wasn't clear which way they were trying to do the claim. But think if we're trying to show that the airline is wrong, we try to show that less than 89% of people get their luggage. So we're trying to cast doubt on that many people are getting the luggage. If we did the does not equals, it could be more than 89%. It'd be less than or greater than. So it makes more sense to test that we would show evidence that not enough people are getting their luggage. For the side-by-side box plots on the project, I used gender and number of piercings and didn't get a box plot for the male side. Well, no, you should have a box plot. So to do side-by-side box plots, Kyle, you want to go over here and jump, and you want to have your data selected. And with your data selected, you want to go to Graph Builder. So go to Graph. Just had points in a line. It should be... So graph, is this the steps you did? Graph Builder. Take the variable you want that's categorical. So go right here and put the categorical variable on the X right here. And then put the quantitative variable on the Y-axis. And then click side-by-side box plots. Does that make sense? And then you want to click the 5 numbers. So I can go slower and do this. You want to make it look nice and pretty right here. But you should have a box plots for both of them. There should be enough males and females in the data set to do side-by-side box plots. Males don't have piercings. Oh, well, there should be some males with piercings. Oh, you're saying, I think I see what you're saying. The mean is 0, but your box plots for males might look a bit odd because a lot of men might have 0 piercings. Yeah. Mm-hmm. Well, not the mean. Remember, box plots show the what, though? Box plots don't show the mean. Box plots show the what. And it might not just be 2 outliers. It might be 2 groups of outliers. Box plots show the medians, right? So let me take a look. I don't want to show the exact one here, but I see what you're saying. It is a box plot, but box plots can look weird. So yeah, good work, Kyle, right there. Box plots can look a little bit odd if a lot of people have the same value. So I'm making your graphic. I see what you're saying now. It is a box plot, but it just looks a little bit weird. So, yeah, no, it's a box plot. Yeah, because of your sample size. Yeah. Mm-hmm. Yeah. And yeah, this is from the fall. I'll show it anyways. But that's actually a box plot right here. So think about this right here at the bottom. No, it's just the way the data is. So this is the way the data is right here. And so when you look at the data, a lot of men have what? So think about where this is at. This is the min, this is the Q1, this is the median, and this is the Q3. So that's actually a box plot right there. That is a box. I see what you're saying. You're saying it's not a box plot, but it is. It's a weird one. It's a weird-ish box plot because a lot of men have what? Like myself. A lot of men have what? It's a weird box plot. I agree with that. It is a box plot, though. That is 100% a box plot. Mm-hmm. A lot of men have no piercings, So you get this weird looking box plot where there's just a large amount of data. So there's lots of men down here on the bottom. You see where it says 313 rows have been selected. So that spot right there, that little line you see right there, which represents 0 piercings for men, is 313 individuals. Does that make sense? Like I can go here and highlight. I don't want to highlight that, but I can highlight this right here, and that's 313. If you highlight the women, you could find out there are, no, it should be, oh, it's highlighting all the women. Ooh, so we don't want that. It's highlighting all the men there. It is. So that is highlighting all the men. Unfortunately, I guess, oh, you can do this. So what we want to do here is we want to do this and then go to rows and go to, this is the weirdest way. You don't need to do this kind of stuff. Invert row selection. Okay, now we're selecting the men who have no piercings. So these are all the men who have 0 piercings. And if we were to subset it, if we go to table subset here, just to show we did this, these are the men. They're all men who have 0 piercings. These are all men with no piercings. So there are 298. Does that make sense, Kyle? There are 298 men who have no piercings. So that little tiny line you see is just that there's a bunch of guys with no piercings. It's just like the minimum piercings for guys is 0, the 25th percentile, 25% of guys have 0 piercings or less, 50% of guys have 0 piercings or less, 75% of guys have 0 piercings or less. So yeah, good stuff right there. Good working with the data and understanding. And thank you, Kyle, for pointing that out. I was like, you should be getting a box plot. You're like, it's a line. And I was like, oh yeah. If the data's all compact right here, then think about this, Kyle, which this is not a bad thing. If a guy has a piercing, he's already kind of a what? Nothing bad about it. Just saying, it's like, oh, you have a piercing, you're a guy? It means you're kind of a what? When it comes to like, just, you're kind of an outlier. Yeah, so just, for women, it's like, and you know what's interesting with women, if you don't have piercings, you're not an outlier. So women who don't have piercings, it's like, oh, you don't have piercings? It's kind of more weird. Not weird. When I say weird, I mean unusual. That's what we mean in statistics. Like that's kind of outside of the boundary of what's expected, the commonality of the data. Oh, we're talking about side-by-side box plots. So if you want to talk about the way Brian is unique, weird, different, like I'm a anime video game nerd, playing Pokemon Go on my phone, streaming on the YouTubes, drinking from my Mario cup with my Mega Man next to me, with my Yoshi. You can't see him because he green screens himself. With my Pokeball right here that lights up. I could go out and catch some real Pokemon right now if I really wanted to. That's how much of a nerd I am. So nothing wrong with being unusual. We are all unusual in our own ways. And when you're unusual, then you're sometimes an outlier. You're not the norm, quote unquote. But why be the norm? Why be the norm? So more fun with my Pac-Man over here. Just you're like, Brian, how much nerdy stuff you got? It's endless. It's endless. There we go. Good stuff. Be unusual. Be weird. Be fun. Be unique. Be you. Do you. So I just felt bad by saying weird. Nothing wrong with anything like that. So anyways, what else do we got? And Brian goes on a rant. I always go on rants. I think we're finishing up, Jackson. We had some really good office hours today. Went through a lot of the problems. This is the, can you do which of the following hypothesis is not appropriate for an alternative? Is that from chapter 15? We'll do that one, finish off. Is that chapter 15? Look at all this work I did on chapter 15. Well, yes, we. Oh, so let's knock it out. Which of the following? Which of the, okay, here it is right here. Which of the following hypothesis is not an alternative? Okay. Well, when you look at the alternative, oh no, jeez. I'm gonna take a guesstimate of that. I need to check that out. Let me put check time. Okay. We'll get that fixed. Okay. The null has the what sign? The null has the what sign? The null has the what sign? Huh? But the null has the what sign? The null has the equals, right? So the alternative can be greater than, less than, not equal. And so the null has the equals. So we wouldn't use that for the alternative. The null is the one that has the equals. So which of these is not appropriate? Oh, wait. Which of the following has the appropriate form for the null? Oh, yeah. So that's the appropriate null. Is there one about which of the following is not an appropriate form for an alternative? Well, oof. Oh, I see what they did right here. So the alternative can be less than, greater than, or not equal to. So, well, so that one was what is the correct form of the null, and I got lucky even though I misread it. Which way is to write the null? It's the equal sign. And then for the alternative, when we do the alternative, what three alternatives do we have right here? So do you see the three alternatives right here? This is a good question. What three alternatives are there? You can see the three of them. So is it choice 1, 2, 3, or 4? Yeah, exactly. We wouldn't do this because that shares the equals which the null has. So yeah, we wouldn't do that because we don't want, number 2. Yep. So when you look at this right here, the signs of the alternative. So I always try to make really good notes while we're taking it to highlight the big things. So great job, Jackson, right there. Once you see like, oh, that's how we do it. That's what it is. There's a lot of multiple choice. When you get these down, you can kind of speed run them because a casino wants to know if it really delivers. Okay, let's do this one really quick. We're going to speed run this. Here we go. We're going to speed run this. If you're watching this in the future, this is a speed run version of this question, just to get one more in the video. Okay. So they want to know if people win this much. That's the proportion of people who win. And the null would be that the proportion is this. And does it really deliver that? We want to see if it's not equal to that. So the alternative would be that it's not equal to. Last year, customers spent on average this. That's the true mean. And that would be the mean. Quantitative is mean. And so the mu goes right here for both spots. The null has the equal sign. Based on the company wants to know if it has decreased, so they're looking for evidence gone down. A pharmaceutical company wants to know if their new drug has a cure rate greater than 30%. So that's the proportion of people who are cured, the true proportion of people who are cured. P is true proportion. That's what they want to understand. And the null would be that it's the same, and they want to know if it's better, so we want to know if it's increased. A bank wants to know if its percent of customers, percent is automatically proportion, use their website has decreased. So that's proportion of customers using the website. It was originally 40%. We want to see if there's evidence that the proportion of website users has gone down. And just knowing how to read these is very important. Really good stuff right there. We've done a lot of these problems here. We've done over half of all the possible quiz questions. But really good. Let P represent the first rate of heart attacks on the new drug. For one to be more effective than aspirin, we want to look at if it's gone. Oh, the null is the equal sign. The alternative is that it's gone down probably. And so then here, since identifying the correct suit, state the right null. Null has the equal sign. All you need to know right there. Null has the equal sign. In a criminal jury, one option is to declare not guilty. In a hypothesis test, this is equivalent to what? We do not accept the null hypothesis. We either reject or fail to reject. So you come in not guilty, and that would be failing to reject what it was originally believed. Talked about that last class. The probability of seeing sample data like these or something more extreme given the null is true is a p-value. P-value is the probability of our results or results more extreme given the null is true. Rejecting the null hypothesis, the p-value is less than alpha. It's small enough, which is smaller than alpha. They should have said less than alpha. That'd be a better way of stating it. Which of the following is a correct interpretation of a p-value that is not very small? That means it was high enough that our results are possible given the null is true. We should reject. We should fail to reject. So it's only between these two. What we saw in the data, sample data, was not surprising, so we should fail to reject because it was what we saw was likely. Oh my gosh, do we almost do everything? 15 right here. The null is that it's equal to that. The alternative, this is the... So then the alternative would be that it's different. Plausible is satisfied. Test statistic of 1.96. Wait, it's gone down right here, right? So 1.06. P-value of 0.05. and we reject. There is evidence has changed. The difference is probably meaningful. Check out, we did an earlier version of this problem right here with this one right here. If you're looking for this problem, if you're watching right now, just want to finish this off for the heck of it. It's probably not meaningful right here. Check answer 83% because I guessed these values. What number did Jackson have? 83.26. Let me look at the work Jackson has. 83.26. So larger sample size, larger sample size, higher t statistic. Higher t statistic, lower p value. Lower p value. We're so close. There we go. Well, that's going to be... There we go. It was very close to what Jackson had earlier, so looking at Jackson's problem right here gave me enough insight. And thus the t statistic would be smaller? I'm trying to think how that works. Trying to backwork the problem in my head. 82.8213, and our problem says it's a good bit larger. So if you have a larger t statistic, that should have led to a larger sample size should lead to a... Oh, the proportions are different. The proportions are a bit different. That changed the problem too. Okay, so that's why it didn't turn out exactly the same. Okay. Still similar, but not exactly the same. Oh, the data. Now I have to do the data. T statistic. I'm just doing this for fun right now. Why not? Let's go over here. Run the data. Ooh, that's such a small sample. It's not weird though. So that means you can do it. And what value are we testing? They purchased 6 with a marked with a net weight of 28.3. Do these days 5? I'm not looking if you don't know much about it. Can you do the students investigate potato chips? I think we're doing it right here. Yep. We're doing it currently. I'll slow down. This question, you need to use jump. So this question right here, you need to use jump. Does that make sense? What do you need to use to solve this question? What do you need to use to solve this question? To solve this question, you need to use what? I mean, you could do it elsewise, but I wouldn't suggest. What do you need to do to solve this question? You need jump. So first thing you want to do is you want to take the data, copy to clipboard, and then hit Control-C or Command-C. Once you've hit Control-C or Command-C, go over into Jump, and in Jump, go to File, New, Data Table. File, New, Data Table. Under File, New Data Table, you want to just go here and go to Edit, Paste. Don't paste with column names because there's no column name. It just is the data as is. Now that you've got the data pasted into Jump, we need to run the hypothesis test. Now they are testing if the true weight of these chips is equal to 28.3. I think they're trying, they want you to find the mean and the standard deviation, so they kind of want you to do it by hand first, but we don't have to do it by hand to find the mean and standard deviation. To find this information right here, go to Analyze. Under Analyze, go to Distribution. So we're going to Analyze Distribution. Then double-click the variable name you want, which is the only variable you have. And now that you've double-clicked that, click OK. Now go ahead up here and hit Stack. And you can see the mean over here, which is 28.8, and the standard deviation, which is 0.4427. So there's the mean, and there's the standard deviation. The independence condition is plausible. The nearly normal condition is plausible. Therefore, we should use the t-distribution. That is your random condition, your less than 10% condition, and the nearly normal because it's quantitative data. So the mean weight is, we just got to get the mean weight right here from the data, 28.8. The standard deviation is 0.4427. How many decimals? Oh, really? I mean, yeah, sure. I mean, I'll let Jump calculate the rest of it. Okay, 0.4427. And then the null hypothesis. So the null hypothesis is where you want to pause and see if you know how to write these things. Because this is the first big step of doing hypothesis tests, is to write the null hypothesis as the null states that the true mean is equal to the hypothesized value of 28.3. So the null states that the true mean weight of potato bag chips is equal to 28.3, and we are testing right here Now, it was above in our sample. Our sample was above that. So I think we are testing the does not equals. They never state if they want to look at greater than or less than, so we're going to go with not equals to. And so we would say that it is not equal to 28.3. Now, what's really interesting about the output right now is I can kind of run the test by looking at the standard error. Ooh. The difference is about 5, so the t-statistic is going to be about 2.5, but it is a very small sample. So this is where I like this problem because it's using small samples, so we might not find statistical significance. So we need to go here to the second red arrow and click test mean. And with test mean, we enter in 28.3. 28.3, which is the null value. Notice how 28.3, we'll show it here in a second, 28.3 is the hypothesized value in the test right there. That is mu naught. So mu naught is 28.3, and then the sample mean was 28.8 right there. That is the y bar. The t-statistic, I said, would be about 2 point something, is 2.7. So that is how many standardized units we are above the hypothesized value, 2.766. And so how many decimals? 2.77 rounded up. And then the p-value for the does not equals is 0.0395. This is the does not equals. This is the greater than. This is the less than. The does not equals shades both sides right here. And just to show this, when you're doing your tests, you can actually do the p-value animation to see what the tests look like. So when you do, they added more to this. So the greater than is the high side right here. The less than is the low side, and the does not equals is the two-sided, which is double the smaller of the two of these. So there is the p-value right here. It is 0.0395, and it lets you even test other things with this now, like increasing sample size. Neat that they did that. 0.0395. So here we are, 0.0395, which rounds to that right there. State your conclusion using the 0.1 alpha. We reject the null hypothesis because our p-value is less than alpha. That means there is sufficient evidence to conclude that it is different from. Now, we have to be careful because they might have been testing that it's more than. We should have got everything correct. We did. They never said less than, greater than, not equals to, so I had to assume that they wanted to do the not equals to test. So without indicating that we want to see if the bags are heavier than we would expect, we would test the does not equals. So if it does not clearly state less than or greater than, you just go with the does not equals to test if there is a difference. And that's a really good question. That's a tough one. And this is the potato bag chips again. So we're just going to do this one here quickly. They want to test 28.1. So it looks basically like the same question. I don't know where the difference is going to be here at the end of this. Maybe it's just like a question where it's not going to be different. So we're going to paste the data again, and then we're going to analyze distribution, take the bags of the weights. And here we are at here. The independence condition is plausible. It's probably nearly normal, so we should use the T. The mean weight of the chips is 28.85. The standard deviation is 0.2073, 0.2074. The null is that it is equal to the hypothesized amount, what they said is true, and the alternative is that it is not equal. The t-statistic, we once again need to run the t-test on this. Go here to test mean and put in the hypothesized value of 28.1 and run it. And we get a t, ooh, this one's even really, no, wait a minute. Something's weird. I guess there was less variation in this. There's a bit of an outlier. Are they going to point that out? I guess so. 8.86. So that's a big difference. Even though it looks small, it's a very big difference. The p-value is in round to 3 decimals. This is going to be a tiny p-value. I'm a little worried because it's a bit odd. The p-value right here is 0.00003, which means it's basically 0 when you round to 3 decimals. Since the p-value is less than the alpha 0.05, we reject the null hypothesis. There is evidence for the alternative that it is different from this. And we were testing different again. Good. We've literally done every problem. So, Lindsay, does that make sense? Do you have any questions on that? I know those a bit quickly, but that did every single problem on this quiz. Check it out if you're looking for them. We did the multiple choice a little bit quickly, but we've now done every problem on Chapter 15 quiz. So really good stuff right here and really good practice. We'll put this in the video pretty immediately, but that's the whole quiz. All the problems, every single one of them. So with that, it's time to end off. Bye for now, everyone. Makes a lot more sense. Love hearing that. Bye, Lindsay. Bye, everyone. Bye.